Hi, I'm Jessie. Today I'm going to present the topic Technology of Optical Communication System. So here is the introduction of this topic. Let's start with the background. So the high demand for the high capacity of the long-distance communication system is due to the internet service developed more rapidly in nowadays world. So in this paper, we're going to discuss about some special technology in order to apply in the system, allowing the good quality of the signal and also the performance of the system. And we will talk about three aspects. First one is the optical communication system, and the second is limitation in transmission system and its solution. And the third one is way to improve the transmission capacities. Firstly, we're going to talk about the topic, the characteristic of single mode fiber. So it has zero dispersion value as 1310 nami, and the attenuation of SMF as this value is larger than 1550, which show in this graph. So we still use the 1550 nami in a long distance transmission is because SMF has very lower attenuation as this value comparing to the 1310. So which is the C band in this range. Also in this topic, we are going to discuss about the characteristic of WDM, which means wavelength diffusion multiplexing. So the signal needs to be converted into the electrical form for amplification and then convert to the optical signal again, which is very costly and complex. So therefore, it's not suitable for the long distance transmission before. Secondly, we're going to discuss about the limitation in transmission system. So the signal loss is the main reason of the limitation in this system, which including the light absorption, Rayleigh scattering, and also the micro deformation, which will affect the quality of data transmission. So we will talk about the Rayleigh scattering, which is most important in the 1300 range, and that's why we can explain why the attenuation in this range of the single mode fiber is very higher. Hence, I would like to discuss about the solution of the limitations, which is erbium doped fiber amplifier. So it's used to compensate the loss of the optical fiber in a long distance communications through increasing the strength of the light signal. Then I will explain the principle of this amplifier. The key component of it is the erbium doped fiber, and second one is pulp laser. Third one is WDM. So the pulp laser provide a necessary energy into an erbium doped fiber, and energy will excite the ions to a very higher energy state. And when the weak optical signal, which is in a C band, travel through the fiber, the photons from the signal will interact with the ions, which in a very higher energy state. And the energy released in the process will in the form of the amplified light. So the energy level is shown in the graph. So it will use 918 nami or neither 1418 nami of the pump laser to excite the erbium ions. So the lifespan of the ions on level 11 is very short comparing to the level 13. So the exercise ion tend to go through to the metastable level on the 13. So how can we improve the performance of the EDFA? So first one is the doping radius. When the doping radius is small, it can improve the maximum gain of the EDGA, and the result is shown in this graph. It's because of the erbium ions are concentrated in the centers. So the second one is wavelength and also the EDFA placement based on the performance of the DWDM system. So as 980 nami and also the 1480 nami pump wavelength, and also the free position, pre-amplifier, inline amplifier, and booster amplifier. So according to the result in this graph, the booster amplifier performance is better than the inline amplifier and also better than the pre-amplifiers. So about the plumb wavelength, the performance of all position in 1480 nami was better than the 980 nami. Lastly, we will talk about the way to improve the transmission capacity. Therefore, in order to expand the DWDM transmission capacity, we can explain from C band to the L band in order to widen the effective bandwidth. And the results show that the transmission capacity will reach 3 times that of just only C band. That is the end of my presentation. Thank you for listening.